Morning.
Morning. You get into school a different way this semester? You come into school a different way this semester?
No.
Oh, okay. It seems like you get here earlier.
I just come here when the doors open.
gave me zeros for 71 and 72, but I wasn't even there the day you assigned them. And
Okay, you have to make up stuff you miss.
I did them and I turned them in late. Should I have emailed you that I did them?
What numbers were they?
71 and 72.
72. Okay, I will check.
Sorry for...
No, it's fine. I usually get an email saying that you turned it in late,
Alright.
but it could have been on a snow day or something, so I may have just missed it.
It's fine.
Thank you.
Yeah. Let me leave these open so I can. Before I get cut off on the minute of silence, if you didn't turn in that 77 in the Google Classroom, you need to do that right now to still get full points. If you wait after right now, it will be late. If you're not sure, double check.
Please stand if you are able and join me in the pledge. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Thank you. Have a great day.
All right, good morning. So there's a couple handouts today, and you will need a textbook today. If you forgot the textbook, if you didn't see the sign, just wait for a minute because you don't need it for the first little bit here. So we need to quickly go over number 78. We need to talk about what the first and second fundamental theorems of calculus are. You actually already know the first fundamental theorem. I just didn't tell you that it was called the first fundamental theorem of calculus. The second one, though, we're going to talk about why it works the way it works and why there's a benefit to recognizing the pattern because it's going to make things quite a bit quicker. And then from that, we're even going to use the second fundamental theorem on handout 79, where we'll do a practice FRQ. Then we've got a book assignment to practice some antiderivative stuff. Since we're getting close to our test, we need to make sure that you guys can execute that. And then finally, probably about the end of class, it'll be finishing up the book work. And then I gave you the test review a little bit early last class, asked you to do at least 5 questions, but I will see you guys again tomorrow. And if I was you, I would come with at least half the test review done so that you have a good idea of what questions you need to ask and you can finish it up tomorrow in class. But let's go ahead and talk about the first and second fundamental theorem. So really I need to verbalize this for the second one, but before we get to that, just a quick little reminder here. There's something called an indefinite integral. Indefinite means you just don't have these bounds, but the antiderivative still works the same. If you're just undoing power rule, raise the power by 1, divide by the new power, and check by taking the derivative. Raise the power by 1, divide by the new power, check by doing power rule. And with indefinite integrals, you have to put the plus c since we don't have the bounds. There could be a constant there that we can't see. So I'm not saying anything new, I'm just reminding you that. The first fundamental theorem is the one that where you show that you know how to deal with these upper and lower limits of integration. So you still do the antiderivative the same way. You're welcome to do plus c if you want to, but I showed you before why that didn't matter, so you might look back at your notes if you want to know why. And we still need to evaluate from 0 to 2. So the first fundamental theorem just says after you do the antiderivative, first time you're going to plug in the upper limit, get a number, then you're going to plug in the lower limit, get a number, subtract those, and you get your answer. So you've been doing that for a while, you just didn't know that that was considered the first fundamental theorem of calculus. I think that comes out to 14/3. So for this class and for the AP exam, you have to be able to do that. You don't have to remember it's called the first fundamental theorem of calculus. Okay, before I tell you the second fundamental theorem, we have there's like 1 or 2 questions on your test review, and there'll be 1 or 2 questions in the book assignment that we'll move on to in a few minutes that ask you to find average value as opposed to total value. So you need to know that if you want to know the total amount of something, you're just going to integrate. If you want to know from -1 to 1, you can integrate this, and that gives you the total value. Because what that's doing is it's taking the value at -1, the value at 0, the value at +1, but also all the values in between. It's adding up all those areas, just like we did with Riemann sums, but we did that manually and it was just an estimation. Integration is adding up all those areas and it's exact, but this is total. So how do you normally find the average of something in a math class? Okay, divide by like however many things there is, right? If I'm getting the average test score in here, I would add up all your grades on a test and divide by how many students took it. So if you want the average, all you need to do is do the same thing, but then divide by how much horizontal distance you're trying to travel. So if you're going from -1 to 1, in this case you would divide it by 2. A lot of times when we write this, we'll just multiply by a half. It'll look like this in the word, because multiplying by half is like dividing by 2. So if you want to know the total accumulation, that's what integration will do. It'll add up everything from that bottom limit to the top limit. But if you want the average, you need to divide it into however many horizontal units it's traveling. Okay, so on to second fundamental theorem. And this is the one time I'm going to go over this in depth, but this is what you don't want to do. You want to understand it and you want to recognize the pattern so that you don't have to do this every single time. But for one time for your notes, I feel like this is worthwhile. So second fundamental theorem is when you try to take the derivative of an integral, and it has to be in that direction. Tomorrow in class we'll talk about if you try to go the other direction, some shortcuts that you can take. So derivatives and integration are inverse operations. They basically undo themselves. But let's just work this out the longest way possible. And by that I mean let's worry about the derivative later. Let's just do this integration here. So raise the power by 1, divide by the new power. Raise the power by 1, divide by the new power. Raise the power by 1, divide by the new power. Check with derivative, check with derivative, check with derivative. Yeah.
says d over dx, but the variable is t.
Yeah, there's two different, these are t's and these are x's. It's supposed to be that way. Two different things. Okay, but I need to evaluate this from -3 to x. So again, we're going to worry about the derivative at the end. But to evaluate this from -3 to x, I'm going to plug in the upper bound everywhere I can. So basically all the t's become x's. Then I'm going to plug -3 into all of that. And I'm just going to use my calculator. Honestly, I don't really care because it's not going to matter anyway. You'll see why in just a second. Okay, plugging -3 into that, you get -1.5. And then of course we're going to subtract those. But now let's turn around, and of course you can make this minus a negative, you can change that to plus if that makes you feel better. But now we're going to turn around and take the derivative. So what's the derivative of 1/3 x cubed?
X squared.
Almost the same thing we started with. What's the derivative of 3/2 x squared?
3x.
Almost the next thing that we started with. The derivative of 2x would be 2, and the derivative of a constant, 0. That's why I said that doesn't really matter. It's going to, taking the derivative of the constant is going to go to 0 anyway. So here's, you can do that sometimes. You can do it the long way sometimes. But I have also seen questions, released AP exam questions, where they will try to phrase the question in a way where you can't even do it this way. But you're not going to want to do it this way anyway once I point out the pattern to you. These two are basically undoing themselves. So the second fundamental theorem says, as long as this bottom number is a constant, it didn't end up mattering what that constant was because we turned around and took the derivative anyway. As long as the bottom is a constant, your answer is going to be this with the upper bound plugged in. So you plug x into t squared, you get x squared. You plug x into 3x, you get 3x. You try to plug x into 2, there's nothing to plug it into, so it just stays 2. So anytime you're trying to take the derivative of an integral and the bottom limit is a constant, you can just plug in that upper bound into all the variables, and you can skip all of that work that I did. It will always follow that pattern. Okay, so now we're going to do the same thing on the back page, but we're going to just do a bunch of them quickly because we don't need to go through the long process. You don't really need to integrate the inside. And in fact, I've tried to make these kind of messy to where you wouldn't want to do that anyway. Now one typo I do have on here, just in mathematics we try not to mix up the variables. X shouldn't represent two different things. So these should really be something else, like a y or a t. I just forgot to change that last year. Okay, so I can answer at least the first three in about no time at all because I know how those two things are interacting. I know the second fundamental theorem, and I've practiced this a few times. Taking the derivative of an integral, as long as the lower limit's a constant, all that ends up happening is this upper limit gets plugged into everywhere there is a constant. So t to the fourth becomes x to the fourth. 5/12 t squared becomes 5/12 x squared. And then you can try to plug x into 1,000, but there's no variable to plug it into, so it stays 1,000. Again, if you want to, I guess you could integrate this and then turn around and do the derivative, but that's what you're going to end up with. Same thing with number 6. Derivative of an integral, the bottom is a constant. So the upper gets plugged in everywhere there's a variable, and you're left with x to the 31st minus 9/11 x to the 5th minus 70. They expect you, College Board expects you to recognize this pattern and be able to do it this way. Again, in just a second, when we go over to our one practice FRQ today, you're going to see how that's going to help you. They're not going to come out and say, hey, do the second fundamental theorem, but we're basically going to be taking the derivative of an integral. Okay, same thing here. It looks different, but derivative of an integral, the bottom's a constant, so the t's become x's, because x was the upper bound. Derivative of an integral, the bottom is a constant. I don't care what that constant is. Look at the bottom of page 1 if you want to see why. But my answer becomes x squared minus x, and then you can try to plug it in here, but you can't. You get 1. If you happen to wanted to know when that happened at x equals 2, then of course you could just plug in 2 into that at the end. Adds one extra step. Yeah, makes sense.
Is it cubed?
Oh, sorry, this is cubed. So this is 8, 6, 7. So it's great if you see why this works the way it works, but at the end of the day, for our requirements in this class and for your AP exam, as long as you recognize that pattern and can do that quickly, then you should be fine. Now, there is one catch. There's one extra step sometimes. There's a chain rule step occasionally. So if we look at this question 1 and do it the same way, again, I apologize, these really should probably be different variables, so let's just make them t's. Okay, so now it's still second fundamental theorem because I'm still taking the derivative of an integral where the bottom limit is a constant. So you can still try to plug all this stuff in. X squared plugged into t to the 4th would be x to the 8th. X squared raised to the 4th power would be x to the 8th. Plus 5/12 x squared squared would become x to the 4th. You can try to plug in x squared here, but there's no variables to plug it into, so it's just going to stay 1,000. And here's the one extra catch. There's one extra thing you have to figure in, and I don't know why, but students usually, not usually, but sometimes forget this. The chain rule part, and again, you can see why if you want to go through the whole process of integrating this by hand and then turn around and undo most of it with derivatives. But if the derivative of the upper bound is not 1, you need to multiply all of this by the derivative of the upper bound. So all of that needs to be multiplied by 2x. That did not matter on the above questions because the derivative of the upper bound was 1. Multiplying by 1 doesn't change anything. Derivative of the upper bound was 1. Derivative of the upper bound was 1. Derivative of the upper bound was 1. But otherwise, it's the same thing. Fits the pattern for second fundamental theorem, so we can just plug this in. We get x to the 93rd minus 9/11 x to the 15th. I'm taking x to the 3rd and raising that to the 5th power minus 70. And all of this has to be multiplied by 3x squared. It is chain rule. I know it's kind of hard to see the chain rule without working it out the long way, but it's just one extra layer to it that you got to add to your thought process. Okay, is this the last one on here? Okay, I want you to go ahead and just write down what you think the answer should be, just as a quick little check. Okay, so it fits this pattern of second fundamental theorem. So this stuff gets to go where x is. So part of your answer should be f of 2x squared. I don't change any of the rest of the function. If it's f of t, now it's f of 2x squared. Just make sure you don't forget the chain rule part. Each time you see one of these questions, it's 50-50. It's either going to have chain rule part or not, but half the time it does. And I think when they do this as a multiple choice question, they always just put this without the chain rule as one of the options because it's a good distractor. A lot of people will pick that. So, not harder, but it does make you do one extra step. Okay, any clarifying questions on second fundamental theorem? Okay, so we will see that on the FRQ. Let's move over to that. And a very common type of FRQ called a rate in, rate out type. So number that is 79. We're going to go through that together. Make sure that you guys remember a few things from last semester and pull this stuff together. Then we'll go on to this book assignment, but when we do the book assignment, we'll do the last part of it first, and we'll do it together because those last questions are really just these type of questions. So we can knock out like 10 questions in just a couple minutes. So we'll practice that one more time together. Okay, so this, as we get closer to our AP exam, this will be one of the type of FRQs that we practice a lot of because you guys will have 6 FRQs on your AP exam, and some type of FRQs are just more common than others. Of course, I have no input. I have no special information to know this is going to be one, but they very often ask a version of a rate in / rate out type of problem, which this is. You've got a function that tells you how much sand is being removed from a beach. That's the rate out. You've got a pumping station that's adding sand, and you've got a function for that. That's rate in. So we know how fast sand's being added. We know how fast sand's being taken away. And with that, we can answer all kinds of stuff. So at between time 0 and 6 hours, we start off with the beach has 2,500 cubic yards of sand. How much sand will the tide remove during the beach during the 6-hour period? Okay, so the most common mistake is people will try to do R of 6. That's not correct. If you plug 6 into R, you're figuring out how much sand's being removed at exactly the 6-hour mark. You're not figuring out how much sand's being removed at hour 1, hour 2, hour 3, hour 4, hour 5, and everything in between. There's no way for us to add up all of those individual pieces, but we have a calculus thing that can do that. It can total up the accumulation for us. So you can do this. You can integrate 0 to 6, and it totals up all of those values. And just to save yourself a little bit of time here, I'm not going to put this stuff in my calculator, but I'll tell you what the answers come out to be if you want to check it, and then tell you how it's scored. So notice I referred to R of t. If you'd rather write out this whole thing here, you're welcome to, but if you miscopy it on the AP exam, you lose that point. You're welcome to just say R of t, and then you're not running the risk. But for this question, you had to get I guess just the answer. I didn't write that down very clearly. So either 31.815 or 31.816 cubic yards. But your calculator can do that for you. Your calculator would have to be in radian mode because there's a trig function there. Everything we do in calculus is radians. Now the reason why they accept 2 answers, by the way, I don't know if I have said this before, but they ask you to always round to 3 decimal places, but they don't care if you round to 3 decimal places or if you truncate. So if you just take 3 decimal places and you don't round up, and it was supposed to round up, they don't count off for that. So. Okay, part B. Write an expression for y of t that represents the amount of sand on the beach for any time t. So to me, this is similar to the circuit you guys did on Tuesday. You've got a starting amount, 2,500, plus integration is going to tell me how it changes. So I could add how much sand is being added, and then subtract how much sand is being removed. And really, you could put these as one statement. Now, that's pretty close to being a function that will tell me the amount of sand at any given time, but I purposely left one mistake on here because it's an easy mistake to make. Any guesses about what that would be? What do you got?
The bounds is supposed to be at any time.
The bounds are supposed to be what to what?
0 to t.
Very good. If you do 0 to 6, this isn't adding how much sand's being added to that specific time. It's adding how much sand there is over 6 hours. I may not want to know how much sand there is at 6 hours. I may want to know at 4.2 hours. So this has to be t, and this has to be t. It depends on how, if you want to know the sand at 4.2 hours, you need to integrate from 0 to 4.2, not 0 to 6. You don't care how much sand's being added or removed from 4.2 to 6. Only 0 to 4.2. Okay, and for this question, they gave 2 points. They give 2 points, I'm sorry, 1 point if you set up your bounds correctly, your limits of integration. And they give 1 point if you set up this part correctly, if you have the S of t minus the R of t, either as one statement or two separate statements. It doesn't matter. So that's all they wanted with that. Now we're going to use this for questions C and D. So you guys okay with how I set this up? Okay, starting amount plus how much you add, take away how much you remove. Okay, part C. Find the rate at which the total amount of sand on the beach is changing at t equals 4. So I know they want t to be 4, but what should I be plugging 4 into if I want to know the rate of the total amount of sand on the beach is changing?
Why?
Okay, y tells me how much sand there is, not the rate of how much sand. So you're close. Okay, backtrack. I think you're correct, but before you got to that, what does rate mean in calculus?
Rate of change.
Yes, but what calculus operation represents rate of change? Derivative. If this represents how much sand there is, then y prime represents the rate of change of sand. We want to know how much at that moment is it being added or subtracted at that exactly 4-hour mark and at what speed. So, well, let's just do t first, and then we can come back and plug in 4. I think that'd be easier. Okay, so we've got this part from part B. What's the derivative of 2,500? 0. What's the derivative of the integral of 0 to t of s of t? It's just s of t. That's the second fundamental theorem that we just talked about on the other handout. If you're doing derivative of an integral and the lower bound's a constant, you get to just plug this guy in. Okay, subtract. What's the derivative of this stuff? Just r of t. If you know that, well, if you don't know that, recognize how hard that's going to be. You're going to have to try to integrate this, and then you've got to use that function up there above, and it's possible to do it with the process called U substitution that we'll learn next week after your quiz, but you don't want to have to do all that. It's a 5-second question if you know second fundamental theorem, and if you don't know it, if you don't recognize it, then you're probably going to get stuck on the rest of this FRQ. Okay, so our answer really comes from S of 4 minus R of 4. And this is a calculator FRQ, so you can just plug those numbers in your calculator, hit enter, and they give only 1 point for this, but they either took this or this, depending on if you round or truncate. But not only is this an important type of FRQ, but I needed you to see that sometimes, bless you, they're not going to say use the second fundamental theorem, bless you. But when you got to take the derivative of an integral like that, that's what you're doing. Okay, and then finally, part D. Between 0 hours and 6 hours, during what time t is the amount of sand on the beach a minimum? And what is the minimum value? Justify your answers. Okay, well, as soon as I hear min or max value, I'm thinking of like last semester. Extreme value theorem does that for us. Extreme value theorem says, actually this would be y of t. Extreme value theorem says that the max and min values, the absolute max and absolute min, will either occur at an endpoint. So I should test these two, although I really know one of these, don't I?
Yeah, 0 is 25.
Right, they told us that at the beginning. You can plug 6. What would I plug 6 into if I want to know how much sand there is? Right, is this answer from part B? But again, this is calculator question, so you're just plugging in 6 for t, plug it in your calculator and let it do the arithmetic. But if you did that, you get 3694. You get that. Okay, so other than endpoints, where else does extreme value theorem tell us we need to check as possible max and min values? Right, we need to consider critical numbers. You have to remember from last semester, critical numbers are when the derivative equals 0. Well, good news. We already know what the derivative is. We just want to know when does it equal 0. We had to do the derivative for part C. So once again, you have a calculator. So we did a circuit earlier this year on using your calculator. You could solve this a lot of different ways. You could graph this, and then you could look for x-intercepts because it said equal to 0. You could add this over, and you could graph this, and then find intersections. I don't know, but you're not wanting, if you look at the functions r and s at the top, you're not wanting to solve this by hand. You need to make sure you know how to do that with the calculator. That happens when t is about 5.117865. 511. I'm just going to round over here. Okay, so if you plug that into y of t, you can figure out how much sand there is during that time. And I would say 95% of the time, the critical number is going to be the spot that has the max or min sand. But in this case, there was actually, what was I trying to find? Oh, the minimum. So I want to know the minimum. The minimum is actually at time 6. So I'd say something like at 6 hours, that's the win. The minimum amount of sand is 2,492.364 cubic yards. So the scoring for this one, to me, I feel like D is asking you to do a lot here. It's asking you to remember how to find max and min values from last semester, find critical numbers from last semester. Of course, that'll be a little bit easier once we start reviewing for the AP exam. The other stuff, your calculator will do the legwork if you know how to make it connect. But I do feel like the trade-off is here, they do give quite a few pretty reasonable points. So they give 1 point if you just show that the derivative needed to be equal to 0, even if the rest of it's wrong, realizing that you needed to figure out critical numbers. They give 1 point if you find the critical number within your work, and then I didn't write this down, but I think they give you 1 point if you figure out that it occurs at 6 hours and the minimum amount of sand was this. So I think there's 4 points there. I didn't write that down in my paper, I apologize. But so yeah, that last one, maybe the last 2 points there are not the easiest, but this was almost a gimme, and my calculator did that for me, so it's just a matter of typing it in correctly. So, but this type of rate in, rate out, where you're adding stuff over time, removing stuff over time, there's lots of these question types. Again, we'll do a handful of these type of FRQs before your AP exam, but this also fits very well in this unit because you have to understand, even though we had a calculator, we have to understand how integration can tell us the total amount of sand, since we can't add those values up manually. Using integration, we can add up the amount of sand or remove the amount of sand over time. With the second fundamental theorem, we can take the derivative of both those parts quickly. Our calculator can solve this. Last semester we talked about when max and mins occurs. I just plugged these values in my calculator, found this value from my calculator, found this value from my calculator, just connecting all the pieces. But this is an important type of FRQ. So let me give you a moment to reflect real quick and make sure there's nothing you want me to say again or any questions you want clarification for. Okay, we're okay with that? Okay. Now again, when you see another rate in, rate out someday, it may not be about sand. It might be about snow, or I don't know. The topic changes, but rate in is increasing at a certain rate. Rate out is being removed at a certain rate. The format of the FRQ is pretty standard. Okay, if you would, get out a blank piece of paper, and unless you just work a lot quicker, most of the rest of the class will be practicing some integration. But like I said, I'd like to do the last part of this quickly with you. So before I put up the whole assignment here, I want us to all knock out the questions 87 through 98. So again, I'll put the full assignment up here in a few minutes, but right now, blank piece of paper, number your blank piece of paper as number 80, and we're going to do the end of the assignment together. If you didn't pick up a book this morning, you need to go get that. So we're going to skip 2 of those questions, but otherwise we're starting off on question 87. I'm on page 326. Let me erase my answers real quick from last class. Okay. So, let's look at 87 together real quick, and I'm gonna give you a minute to knock out the other 8 questions, because again, all these should be quick. So in 87, they tell you what the function capital F is, and in the directions they want you to find f prime. So at the end of this, they want you to find the derivative of an integral where the lower bound is a constant. So just like we did on the notes this morning, this guy just gets to be plugged in, and then make sure there's not a chain rule step. The derivative of x is 1. You don't need to show multiplying by 1. Oh, except this would be x now. Sorry, it's not a t anymore, it's an x. Okay, so copy that one down, and then 88, 89, 90, 91, 92 all look the same to me, and then jump to 95, 96, 97 look the same, but they have a chain rule step. So just making sure that you can answer those quickly and accurately. So I'll give you just a minute to do that, because it really shouldn't take any more time than that. Let's check all 8 of these. So first 5 was derivative of an integral where the bottom limit was a constant. So the first 5 are just second fundamental theorem. X goes into, oh wait, we did that one. X goes into t squared over t squared plus 1. 89, X goes into the square root of t to the 4th plus 1. T becomes x. I'm plugging in the upper bound everywhere there's a t. 90 would become the 4th root of x. 91 becomes x cosine of x. 92 becomes secant cubed of x. If you recognize that pattern, you should be able to answer all of those that quickly. These last 3 are the same thing again. You're still finding the derivative of an integral where the lower bound is a constant. So in 95, you start off with the square root of sine of x. But in this case, the upper bound is not just x. So the derivative of that is not just 1. So you also, for chain rule, needed to make sure that you multiplied by cosine x, the derivative of sine. 96, you plug x squared into 1 over t cubed. You get 1 over x to the 6th. And then because of chain rule, you should be multiplying by 2x. In fact, if you want to simplify this one, you could, because this x could cancel out one of those x's. And 97 also had a chain rule step. X cubed gets plugged into the t squared, giving you sine of x to the 6th. And since the upper bound does not have a derivative of 1, bless you, the chain rule step is multiply by the derivative of the upper bound, which would be 3x squared. Okay, so are you guys okay with 88 through 92? Any of those you want me to say again? I do want you to do 98 as well. I just didn't put it up here, so we'll just do it together real quick in a second. Are you guys okay with 95 through 97? The highlighted part, the chain rule step. Now, I don't know if we will put this type of question on your quiz next week, but we have put it on the quiz in the past, and this was probably one of the more missed questions. Not because this is hard, but because, you know, it's not something that we're going to just sit around and practice the same thing 1,000 times. We've already practiced it like 20 times, it feels like, today. So that's exactly the type of thing that you should review. Okay, but then to quickly do number 98 as well. It also fits that pattern. I just didn't write it up here, so that's why I didn't expect you to have it done. X squared goes in place of theta, so you would get sine of x to the 4th. And then also times what? Times a 2x. Just recognizing that you need to consider that as part of your work. Sometimes you don't need it, but sometimes you do. And when you do need it, as far as what I've seen on multiple choice questions, they always put an incorrect answer for people who forget this part. So that's it. I don't know. There's a lot harder questions in calculus to miss, so I'd like you to make sure you get that one. Okay, so if you want to finish copying down the rest of the assignment, again, we just did the end of it. So, bless you. The 7, 15, 17, 19, those are all asking you to do the first fundamental theorem of calculus, which is do the antiderivative and evaluate from the lower bound to the upper bound, like we've been doing. But I just feel like you need a little bit more practice on doing that. And of course, sometimes you need to rewrite things. So just like last semester with derivatives, sometimes you would do an exponent step or a fraction step or a something step before you did the calculus, before you did the derivative. Same thing with integration. When you do question 15, you probably want to split apart your fraction and rewrite that to make it look a little bit nicer before you try to do the antiderivative. You just try to jump into the antiderivative, you're going to make it a lot harder, and it's not going to come out correctly. So let me give you a few minutes head start, and then I'll come around and try to help out. So roughly, based on my 8A class, you should be just about finished with the book assignment at the end of class. You could have a few left, just depending on how well you know this and how many mistakes you make and how quickly you work with your neighbors and ask me for help. But you should be pretty close to finish with that. And if you happen to finish early, I am also really suggesting that you do the first or half of the review starting with question 1, so that when I see y'all tomorrow, you know which questions you have from the first half and you have half of it done, and that gives you a little bit more a little more breathing room to get your questions answered next class and finish up the review next class. And of course today there's no movement in advisory, so once you do your CAP stuff, you probably have lots of time anyway. Okay, I'm gonna put in these homework grades and then I will work my way around the room. So if you have a question, of course you guys are welcome to pull up the class website. I think all but like maybe 2 of those have videos already worked out of them, so that will of course help you, especially if you just have a specific step you're stuck on or is trouble starting it. But then I'll come around and help you try to get that done before you go.
No, I don't know. That's just.
If that's an X. So raise the power by 1, it becomes X squared. Divided by the new power. And then that's equal to okay.
You can rewrite it as like U minus 2 times U times half.
Yeah.
That simplifies to U to the 1 half minus 2 U to the negative 1 half.
Okay, so yeah, you need to split this up.
It's like you multiply the multiply U to the negative 1
Why
half.
is this so big?
The U becomes U to the 1 half.
See, when I look at this, it looks like U to the first, and it's the U to the 1/2.
Right.
So when you divide things with the same base, you add,
Yeah, that's
you
just
subtract.
minus 2 U to the negative 1 half.
Right, 1 minus a half, that's a positive. And then on the other side, okay, you rewrote that. Okay, so now you can integrate,
And I
and you
took
can raise the
the-
power by
Yeah,
1.
that's right.
Divide by the new power,
And then I got the antiderivative.
power by 1, divide by the new power. Gotta do it twice. I'll come back. For that one, you're gonna have to split it up. So if that U over the square root of U,
Wait a minute, what is
minus
that?
2 over the square root.
2/3.
You gotta split it up, and then you probably wanna try to simplify these.
I think I just
two
took
before
some
you
of it.
worry about the calculus. You don't have one I can help with yet? Four.
Yeah.
You have one, you get a hand on?
We're stuck on number 15. I think I just did some math like that and I fucking knew something.
Yeah, your antiderivative looks fine, so it must just be in your arithmetic at the end. Yeah.
You got it.
This is the correct derivative.
What is 15? No. You don't get to just, you don't get to do, it's like derivatives where you don't get to just do the numerator and then down here it looks like you're doing the denominator. You need to, what was it, U minus 2 over square root of U? Okay, before you even think about calculus, you gotta make this, there's only 2 ways for you guys to integrate it right now. Undo power rule and just undo one derivative that you have memorized. This is nowhere near any of that. So split this up, put this over this, and this over this. Then this simplifies because when you divide things with the same base,
Wait,
you subtract the exponents. This you could bring up as -1/2.
What's the upper bound?
And now that it's written like this, undoing the power rule is not that bad because you just raise the power by 1, divide by the new power. Raise the power by 1, divide by the new power. And then you can plug in whatever the numbers are. Yeah, if you don't make it look like you're just undoing power rule, you don't get to just do the numerator and then do the denominator separately as you want. You guys have any I can get hints on? Not yet?
Yeah.
Wait. That's what you got.
Yes. Yeah. It's like 16/3 minus 2/3.
Yes.
Yeah.
That's why you take 3.
Minus
times 2/3 equals 4.
Negative 10/3 plus 12/3 is 2/3.
Oh, I just read this. I thought the answer was a bunch.
Does anybody have a question I can come over and help with?
Number 27.
27. Okay, so that's going to be.
That's the next question.
Okay. Yeah.
Equals 5. So, this is 5 side of 1. So that 5 is 5.
Okay.
And the answer is 5 is 2.
Okay. So then you got to plug in 0 too.
Perfect.
The cosine of 0 is not 0, so that's why there's something that's shown up there.
Yeah. I think that. wrote it.
Okay.
And then I got cosecant squared minus tangent squared. And what's the integrator?
No idea.
By what? Did I do that one?
Well, you're welcome to split it apart if you want to, but then there's no guarantee that that's going to be helpful is the issue. On this one, 1 minus sine squared, you can make a substitution.
Oh, cos, or,
Yeah, so that one they expect you to know. So if all of that's cosine squared divided by cosine squared is,
yeah.
and to integrate 1 is a whole lot easier than what you're doing. So your process, like your thought process was fine, it's just that it wasn't going to work out by hand that way. And there's no way to know other than just try sometimes. Just got anything I can help with?
For 43, so, like, when I just do the balance from 0 to 2, and then this times the derivative.
Okay, so this is some function. I don't know what it looks like, but I'm just going to pretend like it looks like this. Okay, you're correct about the 0 to 2, right? And then the other function was what, y equals 0?
Yeah.
So you're trying to find the area. Well, the only way to find area under a curve for us is to integrate. You're integrating from 0 to 2. Remember when we say area under the curve, we mean from the function to the x-axis. So when it says y equals 0, they're just letting you know, hey, it's just to the x-axis, which is
Okay.
good. So what was your function?
5x squared plus 2.
So that's what they really want you to work.
Okay, cool.
But you have to understand that integration is area under the curve, because sometimes they say find the area under the curve and you have to set this up and solve it, and so, and then sometimes they just give you this and ask you to solve it, but same thing. Okay, I'm not going to keep bugging y'all for questions, but you got about 20 more minutes. You need to let me know anything you get stuck on that you'd like help on while you're here.
What's the derivative of cosine? The derivative of cosine is negative.
But it's 4 for -4.
Yeah, you gotta change that. The derivative of negative cosine. It's hard to, it's kind of hard to keep up with that because you're used to going in the other direction. Negative. You could, but it's not gonna work out. Well, the best way is to recognize that this numerator is familiar. It's 1 minus sine squared plus 2, right? Because this is so you really want to integrate cosine squared over cosine squared, but that reduces to 1. So you really just integrate 1. So you're going to get or negative, because it's
T
equal.
to the 1 for x. You get 3/4 t to the 4 things.
So plug in power 4, plug in 0, and just try to switch. Not bad if you remember that. So yeah, you can try to split up if you want to, but you're making a wall. So that's it. That is.
Do you know these numbers are
I don't remember. Are you talking about the website? Yeah. No, which one is where? Okay. Well, okay, you got 2 exponents. So if I plug in 4, what's 4 to the 1/2? It's like square root, right? So you can do that. So that becomes 2, and then what's 2 to the 3rd? Okay. So that's how you know. Yeah, so that would be.
Never mind that there.
And if you put 4 in over there, just square root it, times about 4. Minus. So that's what you get when you plug in 4. Now if you plug in 1, it's even easier. Square root of 1 is 1. You raise 1 to the 3rd power is still 1, so you're just going to get 3 over 2. And then again on the right, it's square root of 1. But if you have an exponent like this, you can either do it in either order. You could either cubed it first and then done the square root, or do the square root first and then cube it, whatever it's that should be either. Okay, what about
Yeah,
the
bring it
second?
forward first.
Looks like the same.
I finished the 17. Oh, that's the 7. That's the 17.
Okay, so this is the 4/3. Yeah, the first part looks fine. Right here though, I don't think this looks negative. So when you plug in -1, well, because when you raise it to the 4th power, a negative number times itself, the number of times it's going to be positive. Just like if you square something that's positive.
How did you do 7? No, I wanted to do 5. I was making sure I saw it. Right, we're going to make sure some of the stuff. It was on A41 or A18. I hate doing fractions.
You're asking me to actually do something different. So first off, let's do this by hand. We can do this by hand. If you plug in 1 here, this is like you're raising 1 to the 4th power, and you're taking the cube root. So 1 to the 4th would be, and the cube root of 1 would be, okay, times that by 3/4. It's going to just be 3/4, right? What you're doing here though, So anyway, you need to do this line here, don't do it actually. So what's the problem was, yeah, if you keep saying it, that's what it is. Okay, so you do this versus, this is mainly
It's a really simple problem, but
I think that was the difference in your numbers here.
Here, the negative average one.
Yeah, and your calculator does order of operations, so the exponent first, it's doing one to the power.
Right.
Then it comes back later, it does multiplication of multiplied by negative.
No, but I imagine it's one of those segments.
It's the same thing as you
Yeah.
did like, your
I
negative
don't
two
know.
squared, or you put negative two in parentheses.
Yeah.
That's what
Oh.
he does, you want two squared.
I was thinking
two.
about
You do negative, and then square root of two, it
So you
thinks
can
you want
split it
square
into
root of
one
two.
over
and
cosine
then
squared and sine of cosine squared, and one of those is,
Yeah.
so you can't really.
Yeah.
Yeah, and then you can do.
Except that I don't direct
You have a couple of help with it?
No?
How'd you get this?
That's
Yeah. You said split it into two, but I don't know what the integration over square root of u is.
I just sort of figured out, I just sort of like put it, and I wrote them both, and then I just added another third one, and it worked, so, like. Sort of, what did I do?
I see. So
The X to the positive.
this is right for the average value. And then they're plugging it in or doing something with it. I guess just to find
And then you do plug in the valve.
Okay,
Hardly taken out.
yeah, so for
I
57,
did
so like it asked me to find the average value, so I did that. And
Oh, wait, but the top is
then also asked me for
Oh.
all values of x and then for which the function equals its average value.
I missed the first one.
So if the function is 2, changes x.
Did you end up with them?
And what was the average value?
I think so.
The average value was, well,
I think.
not the number, but it's e minus e to the negative 1 over 2. And
Yeah,
then
one of
like
those
this,
Oh, this was.
about 2.35.
I was related to the question.
Well, because
I wanna know when the function,
so.
Like
is equal to his average value.
Okay.
You can just set those two equal
Like
to each
solving
other. And then it just depends, like if you have the calculator,
the
I would just
legislative
solve
solving
the
tree
calculator.
said that they could.
That's not as confusing as I'm making it now.
Well, also the second half of this question is not that important. The first half, understanding where the average comes from and remembering divide by whatever the difference in balance
Problem
was.
solving, like, from the government's perspective, I guess. I mean, since, make them so that they can't leave the reservation. So, ours wasn't bad, but everyone was really quiet.
That's still zero. Like somehow got it.
Depends on how you wanna do it. If you try to split apart your fraction, you can hit a wall.
Oh, yeah.
Use that fraction. If you recognize that numerator simplifies, then it's not too bad.
My brother is taking his FHS like tour right now because he's in 8th grade. So I'm gonna leave after this and go get him a lunch.
So the numerator is really just cosine squared. So integrating one is a lot easier than integrating the rest of them.
Okay.
And then
You still need to integrate and plug it out.
First. I found that a derivative of like I found that the derivative of one over the derivative.
yeah.
Two squared. Yeah. Then I multiplied that by two. Because they're
Yeah, I'm not
one has
gonna go that way because the lady is so worried about food. I literally like I wasn't feeling very good, and I was like, and I was still like observing treatment like I was 10. So I got I barely drank because I didn't drink it because I saved it to drink it when I was in class. And then when I said no for everybody, I was like, I'm gonna get to drink it. That's okay. So I'm gonna go that way because I told them to. And they don't really care. So.
It's right here.
I'm just gonna see. I'm just gonna put it in my folder, and then I'll just put it.
So I wouldn't change it to that, just say pi minus, and then cosine that pi is -1.
It's weird.
And then you still need to plug in.
Yeah. They're kind of good. My brother is an 8th grader also, but.
It sounds like, I think it might be used for plugging in. That would change the sign.
Try to figure it out now. You're lost. It doesn't matter. You're gonna get one of those.
All right, guys, I'm sorry I didn't give you much warning here, but you might want to consider taking a picture too of these book pages if you have time to work on it during advisory. Otherwise, I will see you tomorrow. Tomorrow's a B-Day.